So this question's about distance time graphs, and we have to think about how they get interpreted. So first thing is always work out the scale of the graph. So we can see going up here, each square is going up in 1 kilometre because we know the units are kilometres, and along here we're going in 10 minutes, 9:10, 9:20, 9:30, 9:40 and so forth. So one of the important things to remember on any graph is think about the scale of the graph. What is each square worth? And go down to the smallest square you can. And on distance time graphs, we've got to realise that anything that's going at an angle here rather than horizontal or vertical is about the speed, but it's distance and time. And it's about constant speed. So here we're saying that there's a constant speed of something. Then we've got a horizontal line, which means we're not moving any distance, but time is going on. So here's an example of where people are at rest, or you're staying at the same place, you're not moving. And then we've got another constant speed increasing up there. So basically we've got to go through the question. So it says, for how long did she stop? Well, here's where she stops, and we've worked out the scale of the graph. That 1 square is worth 10 minutes. So that should be a fairly straightforward mark to get. The next part of the question says complete the graph. So we've got to think about what they're asking. They're saying Jasmine stayed at the park for half an hour. So that's going to be a horizontal line for 30 minutes. Then she walked home at a speed of 7.5 kilometers per hour. Well, that means she's going to come home at a constant speed, and the line's going to be at an angle of some kind rather than horizontal or vertical. So we need to work out the time that journey is going to take. So do this in several ways. We might have an idea for the speed triangle, speed, distance over time. We might write the rule out, speed equals distance over time, divide by time. You know, whichever way you do it, guys, you need the formula written down so that you can then use it. So this question needs you to plot on the graph the time taken to get home. So in other words, we need to get the time. So we can either cover that up and see that distance is over speed. So we can write time is equal to distance divided by speed. Or we use the idea that rearranging means that these two will switch over. Divide by time will come across as a timesing. Then speed times time will come across as speed will come across as a divide. So whichever way we do it, we end up with the time being found by doing the distance divided by the speed. So in the graph, we can see that the distance away from home was 5 kilometers, and they're telling us the speed in the question was 7.5 kilometers per hour. So the distance was 5, and the speed was 7.5 kilometers. So calculate a paper again. So 5 divided by 7.5 is 0.6 recurring. Now it's really important here you do not round the answer, because we're not at the end. So we write down the whole thing, so either 0.6 recurring or 0.666. Now with all questions we should write down what the units are, if there's a unit to go with it, so that we know what we're dealing with. Here we're dealing with 0.6 hours. This question is working in minutes. It's not easy to plot 0.66 hours. So we need to turn the hours into minutes to make it easier. So what we do there is the 60 minutes in the hour, so we times by 60 and we get an answer of 40 minutes. So the time it takes to get home is 40 minutes. Now we could have done that another way, because there is a relationship, if you notice, between 7.5 and 5. So basically 7.5 kilometers per hour, you can think of it as 2.5 kilometers in 20 minutes. 3 20 minutes in an hour, so if I divide that by 3 I get 2.5, and therefore it would be 5 kilometers in 40 minutes. So quite often on these speed, distance, time graph questions, there is a kind of a nice relationship between the variables. They're more interested in testing your skills on knowing which way to use the formula and how to then work out the number of minutes and so forth. So we did say that the 30 minutes she stayed at the park would be a horizontal line, vertical or horizontal line, and then the scale was 10 minutes every square. And from here we then need to add on 40 minutes, so 10, 20, 30, 40. So this is when they arrive home. So because it's a constant speed, we know it's going to be a straight line where we join together the points. And that's what the speed, distance, time graph should look like for the conditions they've given us here. So we're just got to be a little bit careful that we work with the speed formula properly, or we can do it by logic if the numbers work nice, that we could work out how long it takes by cancelling down the 7.5 speed into so many kilometres per so many minutes and so forth. Either way, that's what the answer should be.